Finishing off from the esophagus, we move into the stomach now. Now noticing at the stomach, here we have the esophagus right up top here. That will lead into the stomach. And then leading away from the stomach is going to be the small intestines. You see the duodenum there. But in the meantime, we need to focus on the stomach and what's in between. The stomach itself has 4 main regions. We're going to have the cardia region. That's the initial region here. We then have the fundus region, which is the very top portion. We then have the body of the stomach, which is the main chunk. And then we have the last region, which is going to be the pylorus region. And that's down here, the pylorus region. In the pyloric region, you'll notice there is the pyloric antrum, the pyloric canal, and the pyloric sphincter. So we mentioned that there was a sphincter up here before. That was the lower esophageal sphincter, the cardiac sphincter. We now have the sphincter down here, and that's the pyloric sphincter. The idea is both sides of the stomach are contained because of sphincters. You're controlling and preventing backflow up, and then you're controlling how much is moved into the small intestines via the pyloric sphincter. What else you're seeing here? You also then have the lesser curvature and greater curvature. Lesser curvature goes to the lesser omentum. We'll get to that next slide. And greater curvature goes to the greater omentum. Again, we'll mention that next slide. The muscularis externa is unique in the stomach because while the entire GI tract is 2 layers, muscularis externa in the stomach is 3 layers. You picked up an extra oblique layer. So it's deeper in the other 2, so it's closer to the lumen. It's meant to help really mix and churn everything up more. Because your stomach is constantly churning and mixing up what's inside of it. So you have plenty of musculature to do that. And that is also aided by these rugae. They're all little folds and ridges inside the stomach. It's helping to increase surface area and helps move things through and mix them a little more too. So you have those rugae inside there. All right, so that lesser omentum and greater omentum I just briefly mentioned before. The idea is the lesser omentum is a connective tissue. It's a membrane. Connects from the liver to the lesser curvature. Helps kind of keep things in place, keep them in the right locations. The greater omentum is a little different. It's not really trying to keep it in place, but it goes from the greater curvature and kind of just drapes down over the intestines. So it creates this kind of covering that quite often has a buildup of lipids or fat in it. So you can kind of see this whole thing right here is all greater omentum. Now in this dissection, it is kind of missing. It would normally come all the way down. So there is a little bit that was torn up and moved as they went through the dissection. But it's just this membrane that covers the entire intestinal area. Here you can see the greater omentum is cut away there. It would be covering still. But you can see the lesser omentum. So if you kind of lift the liver up a little bit and look deep inside, you'll see from the liver to the lesser curvature, that is the lesser omentum. So it's trying to help keep things in place and keep the orientations of where you have the liver and stomach. All right, nerve supply. Because just like everywhere else in the GI tract, you have to have control. The autonomic nervous system, ANS, is where you're looking for control here. That means you're both sympathetic and parasympathetic. Now, sympathetic is from the splanchnic nerves and the celiac plexus. So that's your sympathetic control. While the parasympathetic, hopefully that can ring some bells saying, hey, it's the vagus nerve. That vagus nerve, that cranial nerve, really controls so much throughout the entire thoracic area. So you're going from the thoracic all the way down to the abdominal, everything here is controlled. So we're looking at vagus nerve as the parasympathetic control. So both sympathetic and parasympathetic. Blood supply comes out of the celiac trunk. Go back to the last unit, hopefully remembering aorta comes down, celiac trunk comes right out from the aorta, then splits and branches from there. You have that gastric artery coming off. For the veins, that means you're looking at the hepatic portal system. So you'll be taking this blood and heading back to the hepatic portal, which goes back into the liver for filtering. Now I know the stomach isn't really doing a lot of absorption, but it's still being tied into the same system. So celiac trunk arteries, hepatic portal veins. Now in the stomach, we still have the same 4 tunics, but the difference is there's 2 tunics, the mucosa and muscularis externa, that are going to be unique. They have special features not found anywhere else in your GI tract. Now I mentioned already that the muscularis externa is going to have 3 layers of smooth muscle. These 3 layers, you still have the same circular and longitudinal, but now you also have the oblique layer inside the muscularis externa. The oblique layer is the deepest of the 3 layers, closest to the lumen. These 3 layers are really responsible for mixing and churning. They're helping to move all that solid food back and forth and mix it up inside your stomach. Now, if you only had a liquid diet, that would be really easy. But because most people don't have just pure liquids, there are some solids, that causes more churning and mixing and takes more force. So that means these 3 layers now of the muscularis externa are unique only to the stomach to add that extra power to really churn and mix. And you can see the 3 layers here. The longitudinal layer is the most external of the 3. The circular layer is kind of in the middle, and the oblique layer, the unique one, is the deepest, going closest into the lumen. So 3 different layers of the muscularis externa. Now, the mucosal tunic still has the same basic idea of epithelial tissue, you have the lamina propria, you have the muscularis mucosae, it's all the same there. But we have some extra parts, some extra features. You're looking at simple columnar epithelium found here, because that simple columnar can secrete mucus out of the goblet cells. So that mucus then is going to help to coat the entire inside line of the stomach. By doing that, it's trapping a bicarbonate-rich fluid under the mucus. That's important because this bicarbonate-rich fluid works as a buffer for the acidic environment of the stomach. Because your stomach is very acidic. Floats around a pH of 2 or 3 quite often. It can even dip down a pH of 1. So that's a very, very acidic environment. And if it reaches the actual simple columnar cells, it can destroy them. So this mucus layer with the bicarbonate trap below it creates a barrier and then a buffer. So if it does reach that, the very acidic components, all those hydrogen ions, can be trapped and it becomes more of a neutral or at least less acidic solution coming in. So it's important to make sure, one, that we have this base kind of mucus sitting right there. But 2 are the gastric pits and gastric glands. Now these gastric pits and gastric glands are right here. What you're looking at is the very top portion is the gastric pit. Below that is going to be the gastric glands. Now these gastric glands are going to have specialized cells. You can see you have the chief cells here. You have parietal cells. You have enteroendocrine cells. Each one is specific for what it's doing. And we'll have to get into that a little more later. But the idea is these gastric glands and gastric pits are a modification of the mucosa. So we have both the mucosal layer as well as your tunic for the muscularis externa being unique in this case. So a little bit about the stomach anatomy as well as the special features found in the 2 different tunics.